Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. Okay, so we have been discussing some numerical problems from Conscience Physics book, class 9. These problems are related to motion in one dimension. Okay, so let us see what does the problem says. The first problem says that a spacecraft, okay, very good. A spacecraft is flying in a straight course with a velocity of 75 kilometer per second. So it has been given in kilometer per second. uh, Initially traveling with, so as I have said, that is very important to note down the given facts. Okay, so according to the question, the facts that have been given, let us just first note it down. So this is solution number 1. Okay, so what are the facts given? So let us see. First of all, the initial velocity has been given. Okay, initial velocity. So initial velocity says it's 75 kilometer per second. So just let us go through the problem once. It fires its rocket motors for 6 seconds. At the end of this time, its speed is 120 kilometer per second in the same direction. So this is the final speed. So we need to find out the spacecraft's average acceleration while the motors were firing. Okay, so basically we have to find out or determine the acceleration. And the second is the distance that the spacecraft has traveled in the first 10 seconds after the motors were started. Fine. So for this, what you need to do, we need to actually find out the acceleration and the distance. These are the main two objectives. So in order to do this, let us consider the or write down the given informations. So initial speed, as it is said, initial speed we denote it by the letter u. Okay, so it is, how much it is given? It is given as 75 kilometer per second. So it's 75 kilometer per second. Final speed is actually v, then by letter v. It's it says it is 120 meter per second. So it is 120, sorry, not meter per second, rather kilometer per second. Okay, uh, time for which the rocket motors were operating is 6 seconds. Okay, so time for which time for which rocket motors operated. Okay, so let us consider that to be time t. Okay, and it is 6 seconds. Fine. What else has been given? Next thing that is given is how to find the spacecraft's average acceleration. Okay, so you know that there is a formula which is like v equals to u plus at. I think this formula is known to everybody by now. Okay, so v is equals to u plus at. Now if I consider that the acceleration is a, then initial velocity denoted by letter u and final velocity by letter v, time with the t. So they are related, this quantities are related by the formula v equals to u plus at. So from this we can say that acceleration a is equal to v minus u, v minus u. Okay, so v minus u by t. Now v minus u, so it's 120 minus 75, okay, by 6. So 120 minus 75, how much it turns out to be? It's 75. 120 minus 75, 40, 45. Okay, so this turns out to be 45 by 6 kilometer per second square. Now if I consider this to be in fraction, so 315, 3 to the 6, so basically it gives out 7.5. so acceleration, or average acceleration rather you can say, is 7.5 kilometer per second square. Okay, fine. Now what the second part of the problem says? The distance traveled by the spacecraft in the first 10 seconds. Distance traveled by the spacecraft in the first 10 seconds. So next what we have to find out? We have to find out the distance. Okay, so let us see. Now see, the rockets were operating for time span of 6 seconds. So here we will get two parts. First we have to determine the distance traveled by the rocket while it was accelerating. So that can be obtained by the formula, s equals to ut plus half at square. Okay, so let us consider that. Then in that case the time will be taken as 6 seconds. Okay, fine. So let us take it as s1 equals to, okay, s1 equals to u t1 plus half a t1 square. Why we are considering here 2 t1? Because let us just split the time into two parts. First initial 6 seconds when the rocket was accelerating, and then the final 4 seconds when the rocket was not accelerating but rather just moving with a constant velocity. Okay, so first part of the displacement, how much will you get? So u is initially 75 km per second. So 75 into 6 plus half into acceleration turned out to be 15 by 2. Okay, so let us take it as fraction, it will be easier for calculation. Into t square means 6 square, so it's 6 into 6, so it's something like this. Okay, now 75 into 6, 6 5 to 30, carries 3, 6 7 are 42, and then it's 42, and then it's 3 45. Okay, so it is something like this: 6 5 30, carries 3 42, and plus I add 5 7 45. Okay, and here it turns out to be 3, again here 3, so plus it should be 15 into 9, so 15 into 9 it turns out to be 135. So you add up, how much does it become? It becomes 550, 585, so it's 585 kilometer. Okay, now the second part, when the motors were switched off, the remaining 4 seconds the rocket moved up with a speed of constant speed. Okay, so for this we have to first of all see that the final speed it became was 120 km per second. So the next 4 seconds the rocket actually moved the distance with a speed of 120 meter per second. So for this again you have to consider s equals to ut plus half it square, but here actually we'll consider that s equals to u2 into t2 plus half a t2 square. Now this turns out to be 0, as because in the next 4 seconds the acceleration was 0, so this acceleration is 0, hence it will be something like this. So the expression turns out to be u2 into t2. U2 is actually 120 km per second. Why? Because after the 6 seconds the rocket acquired a velocity of 120 km per second multiplied by the time 4, this turns out to be 480 kilometer. Okay, so the total distance that the rocket traveled under this condition is, therefore total distance traveled is equals to 585 plus 480. So how much does this answer out? 5 8 plus 8 16, carries 1, 4 plus 5 9, and 10, so 1065 kilometers. So in total it goes around a distance of 1065 kilometers. Fine. Okay, so I think the first problem is clear to all of you. Okay, fine. So we'll be now moving on to the next problem. So it's solution number 2. Okay, so let us see what does the second question is all about. Second question says the train is moving at a 90 km per hour speed. So this is the initial speed. Again, you must be first noting down the given facts. So given is initial speed. So initial speed is 90 km per hour. Initial speed is equal to 90 km per hour. Okay, initial speed is denoted by the letter u. Fine. Then brought to stop by applying brakes. That means final velocity or final speed turns out to be 0. Final speed v, this turns out to be 0 kilometer per hour. Okay, fine. Then what has been said, produces retardation of 0.5 meter per second square. So retardation is 0.5 meter per second square. Now we must be converting the speed into meter per second because acceleration has been given in meter per second square. So kilometer per hour converted to meter per second should be multiplied by how much? 5 by 18. So if you multiply this 5 by 18, it will be turning out to be something like this, 25 meter per second. Okay. Third point given is acceleration. So acceleration is equals to 0.5 meter per second square, denoted by the letter A. Okay, fine. Now what else has been given? Okay, so we need to find out the velocity after 10 seconds. So again, very simple. We will be applying the formula. V is equal to u plus at. So initial velocity is 25 meter per second plus acceleration is 0.5 into 10, because it doesn't say after 10 seconds we need to find out the velocity. So this turns out to be 25 plus 5, that is 30. So therefore velocity after 10 seconds, after 10 seconds turns out to be 30 meter per second. Okay, fine. Now the next part, time by the train to come to rest. So for this, what you need to do, for this we need to again apply the formula v equals to u plus at, but here v will be taken as 0. We will be again applying this formula v equals to u plus at. Okay, that is same formula we will be using, but the values will be different. Here the v will turn out to be 0. So 0 is equals to initial velocity is 25. So it is having me a retardation. Okay, sorry, there is a mistake here. It has been given that the train retards. Okay, retards at a 0.5 meter per second. So if we consider acceleration, so this will be negative. A negative sign must come here before the this. Okay, so a negative sign must be written here, negative sign. Okay, so if I consider the negative sign, then definitely this will be subtracted. Okay, so this needs to be subtracted because it is retarding, so velocity must be decreasing, isn't it? Velocity must be decreasing, so this will be minus, so it should be 25 minus 5. Okay, 25 minus 5, so this must be having a different value. What should be the value? It should be 25 minus 5, that is 20 meter per second. Okay, so the correct answer is 20 meter per second, not 30 meter per second. Okay, fine, so it's 20 meter per second, and here you will be also applying the minus symbol. 0.5 into it to find out the time during which it comes to rest. So let's consider this time to be t. So time t will be equal to 25 by 0.5, that means 25 into 10 by 5 cancels out, 5 10s are 50, so this turns out to 50 seconds. So time required to stop, because time required to stop is equal to 50 seconds. Okay, so this is the solution. Fine, so I think the problem is clear. Okay, so there are two solutions. I think there should not be any doubt in your mind. If you have any doubt, please do mention it in the comment box. We'll be happy to solve your problem. Okay, we'll be soon uploading the next video. Till then, please do study well. Thank you. Goodbye.